This video discusses the linked map, a close relative of the org chart. The characteristic they have in common is the set of parent-child relationships. In a linked map, each topic, except for the root topic, has a unique parent, just as each employee in an org chart, other than the CEO, has a unique supervisor. These parent-child relationships can be spelled out very compactly in the dataset by using just two columns, one for the topic itself and one for the parent. If a topic doesn't have a parent, it is the root topic. A primary candidate for a linked map is the hierarchical data found in a supermarket. Products such as meats, dairy products, and others tend to have a hierarchical structure: category, subcategory, sub-subcategory, and so on, down eventually to individual products. For example, consider the cereals section. One way to categorize cereals is by brand, and then within each brand by whether they are targeted primarily to kids or adults. If you want to show this hierarchy with a big picture map, there are two possible types of maps you can use, and both will be illustrated here. If you define the hierarchical structure with two columns, one for topic and one for parent, then a linked map is appropriate. Alternatively, if you flatten the database design so that each row corresponds to a particular cereal and shows the hierarchical structure for that cereal, then a data map is appropriate. Neither type of map is necessarily better than the other. It all depends on the structure of your dataset. The dataset you see here is appropriate for a linked map. The individual products start in row 15, whereas categories appear in rows 2 to 14. The categories start with the root topic, all cereals, in row 2, which has no parent. Then 4 brands appear in rows 3 to 6 that follow from the root. Next, each brand is divided into kids and adults categories in the next 8 rows. Each individual cereal from row 15 down has one of these 8 parents. Actually, a few products, such as Kellogg's Frosted Flakes, tend to appeal equally to kids and adults, so they have 2 parents. The quantitative data in columns C to H can then be used for calculations in the linked map, and it makes sense to roll some of these up. For example, it makes sense to show the average number of calories per serving over all cereals or over all Kellogg cereals. However, there are no quantitative data for the categories themselves, such as a price for all Kellogg cereals. In this case, the big picture convention is to enter asterisks for the categories in the quantitative columns. This indicates that these category topics are candidates for roll-ups, but they don't have meaningful quantitative data themselves. Now I will create a linked map from this dataset. When I click the linked map item on the big picture ribbon, I get the tab dialog box you see here. It has already been filled in, but I will explain the various options. The Definition tab lets you select the data range, including the labels in the top row. Then you specify the hierarchy. In this case, you link each topic in column A to its parent in column B. Finally, you can choose the columns to display. In this case, only the topic in column A is displayed. The Pictures tab allows you to add pictures from a specified folder, where the names of the pictures files match one of the columns, in this case the topic column. Actually, there will be pictures only for the individual cereals from row 15 down, not for the categories. The Calculations tab indicates that averages of the 4 items listed will be rolled up to the various categories. For example, the average calories per serving will be shown for all cereals in the Kellogg's brand. The Markers and Filters tabs aren't used here, but markers could be used to show other information about the cereals, and filters could be used to filter out some of the cereals. Finally, the Display tab provides several basic options for the map itself. The settings here indicate that different levels of the map will be colored differently. the map will be placed on a new worksheet in the same workbook as the data, and the orientation will be from left to right. You can experiment with any of these settings. Now I will generate the linked map. As you can see, I can now drill down from the All Serials topic to individual serials. Note that BigPicture's Auto Arrange and Single Expand buttons are both selected. This is not absolutely necessary, but it is a good idea for linked maps. In particular, Single Expand means that if you expand one of the topics, the others at that level will collapse. The summation buttons show the averages requested. Of course, for the individual serials, these aren't averages. They are the original data for that serial. I can change this example slightly, as shown in this data sheet. Now there are only 2 children of the root topic, kids and adults, and their children are the brands. With exactly the same settings as before, the only change in the linked map is the order of the topics. I'll create it. As I mentioned at the beginning of this video, the type of map you use depends on the way your data are structured in the first place. The datasheet you see here shows a flatter structure, where there is a row for each individual serial and 2 columns to indicate the brand and audience. This structure is completely equivalent to the structure shown earlier, but it would be a nuisance to have to convert from one to the other. If you happen to have this structure, a data map is the type to use. In this case, I have filled out the data map dialog box, as you can see here. The definition tab lists the 2 categorical variables, brand and audience. And the End Topics tab lists individual serials, as well as roll-ups for calories and sodium. I've already created the data map. Here it is. It's very similar to the linked map shown earlier. For more information on data maps, you can view the data maps video in this series. In summary, a linked map is useful when your data is designed so that 2 columns show the parent-child relationships in the data. In this case, a linked map is essentially an org chart, except in a different context. However, as this video has demonstrated, a linked map is often equivalent to, and can often be replaced by, a data map. It just depends on how your data set is structured.